Hi guys, a really nice short lesson today, and basically dealing with what we looked at in the first lesson. We are going to be now solving exponential equations with a common base. The other day what we were doing was just kind of simplifying exponential expressions by converting to a common base. Today we're going to do the same kind of thing, but we want to solve an equation, which again at the end means I will have a value for my variable x equals 3, x equals -5, okay, something along those lines. And again, the nice thing about equations is we can always take that solution that we came up with, substitute it into the original equation and see if it satisfies the equation, which makes the left side equal the right side. And if that is the case, then we do have the correct solution. Okay, so that's what we're gonna take a look at today and what we're gonna work on. Okay, so first thing is we are taking a look at the warm-up activity or the review there where it says simplify that expression, okay, by converting each term to a common base. So what that means is I'm focusing on these bases of 9, 27, and 81, and I want to, if possible, write them all as powers that have the same base, okay, and that common base in this case is going to be 3, okay? So what I do is I take the 9 first, and I write that as 3 squared. So there's the value of 9, and that value of 9 is still to the exponent of 2x plus 3. I'm going to divide that by, and here's 27, right? 27 is 3 cubed. So I'm going to divide that by 27, and that is still to the exponent of 3x minus 1. Okay, so I have to do that first. It's indicated in the question because it's inside of brackets. I'm going to take the value from there. I'm going to multiply it by 81, which is 3 to the exponent of 4. So there is the 81, and that's still to the exponent of x minus 1. So like I said, I was after common bases of 3, and you can see there are all the common bases of 3 that I was trying to get. So from there, what I do now is I use my law of exponents. So this will be 3 to the exponent of 4x plus 6. Okay, and again, if you're confused as to how I got that, okay, by doing this, distributing, I'm going to divide by 3 to the exponent of, this will be 9x minus 3, and again, that is arrived at by doing this. Okay. Again, this needs to be done first, and then after I will do this. So 3 to the exponent of 4x minus 4. So inside of the brackets here, okay, what we're doing is we're dividing powers, okay, but they have the same base. So the law there is that we subtract the exponents. So this will be 3 to the exponent of 4x minus 9x is negative 5x, and 6 minus negative 3 is a positive 9. Okay, and now I have to multiply it by 3 to the exponent of 4x minus 4. So what we're doing now is we are going to multiply powers that have the same base, okay, and in that case, we add the exponents. So this will give me an answer of 3 to the exponent of negative 1x, okay, that's what I get when I take negative 5x and add to 4x, and then 9 minus 4 is a positive 5, okay? So 3 to the exponent of negative x plus 5, okay, is the simplified expression from what they gave me at the top of the page. All right, so we're going to do stuff that looks like that, but now, like I said, apply it to solving equations, okay? So again, just a nice definition, an exponential equation, okay? An equation where the variable, okay, is the exponent. Okay, that's how we know we're dealing with an exponential equation. Use the following procedure to solve an equation where the variable is the exponent. Okay, write each side of the equation in the same base. If necessary, we're going to use exponent laws, just like I did in that above review example, so that each side of the equation contains only one base. We're going to equate the exponents and then obviously determine the value of the variable. And if need be, we will verify or check our answers. So first question here. 5 to the exponent of 2x plus 3 equals 5 to the exponent of 7. Okay, no work needs to be done here to create common bases because I already have a common base. So at this point, I can just say, therefore, 2x plus 3 equals 7. Okay, I can automatically just equate the exponents. So 2x will equal 7 minus 3, which is 4. Divide both sides by 2, okay, and you'll end up at x equaling 2. Okay, that is your solution there. In the second one, okay, obviously I do not have common bases, so that's my first goal here. So most likely I'm going to be able to write 343 as a power with a base of 7, and I can. That is 7 to the exponent of 3. Okay. Now my situation is almost exactly like A. I have the common bases, so I can just automatically equate the exponents and then add 2 to both sides of the equation, and I get x is equal to 5. All right, in C, very similar here, okay? I look at the values there. They are not the same base, okay? But I know I can actually write 81 as a power with a base of 3, and that is 3 to the exponent of 4. So 3 to the exponent of 4, there's your value of 81. I still have to raise it to an exponent of 3x. So the left-hand side of the equation, I will leave like this for now. As I clean up the right-hand side, 4 times 3x is 12x, okay? And now at this point, hey, we're good to go because the bases are the same. So I equate the exponents like so. Get all of the variables on one side of the equation, okay? And that means I will take the constants to the other side. So you'll get negative 7x equals 1. Divide both sides by the negative 7, so x will equal negative 1 over 7. Okay, last one for this page here. All right, so this one a little trickier, okay, a little bit more work to do. On the left-hand side, I have 3 to the exponent of x. Now I have 27 root 3, which means 27 times the square root of 3. So what I will do first is deal with the 27. So that is 3 cubed. Okay, so there is the 27. Now, the square root of 3, okay, this right here, okay, I can rewrite as 3 to the exponent of 1/2, okay? If you remember that anything that it's a square root, I can write to the exponent of 1/2. So, on the left-hand side, stays as 3 to the exponent of x. Now, what am I doing on the right-hand side? I'm multiplying these two things, right? Multiplying, and they have the same base, so I add the exponents. So this is going to be 3 to the exponent of, okay, and if you have to figure it out on the side, I'll show you again how to do that. I'm going to add those exponents together. So this will be 6 over 2, that's what 3 is, plus 1 over 2. Okay, so that's going to give you 7 over 2. So that is going to be my exponent right here. So 3 to the exponent of 7 over 2. And now that you've done that, really, okay, you've done the toughest part of the question. So you just equate the exponents. X equals 7 over 2, and there are no additional steps past that point. You've already isolated your variable. So you are good. You got the correct solution there. Okay, let's go on to the second page, okay, and we're just going to take a look at a word problem here, but the process is almost identical. Okay, so it says here, a bacterium triples every 6 days. The number of bacteria N after X days is given by the following formula. After how many days are there 243 bacteria? So they want to know how many days, okay, and again, when you take a look at that equation that they've given you, X is the days, okay? So you are after that variable right there in the equation. So I take the equation they gave me and I substitute 243, the number of bacteria, in for N, okay? And I have 3 to the exponent of X over 6 on the right-hand side. So just like the questions we did on the other page, okay, I'm hoping I can write 243 as a power with a base of 3, okay? And I can. That is actually 3 to the exponent of 5. So now I have 3 to the exponent of 5 equals 3 to the exponent of x over 6. Okay, I'm at a good point here. I have common bases, so therefore I can just say 5 is equal to x over 6. Okay, and from there, pretty easy to solve. I now multiply both sides of the equation by 6, so 6 times 5 is 30. Okay, so 30 is equal to x. Okay, and again, it's a word problem, so I'll just say, you know, that was 30 days. And we're good. Okay, last two for today. Like I said, nice short lesson, and then you'll have some time to practice this, okay? Solve the following exponential equations by converting each side to a common base. So in the write-up of the question here, they're really nice to you. They actually tell you how to go about doing it. Okay, so in the first one, the numbers I am focused on are the 27 and the 81. Okay, so again, what I want to do is trying to determine which powers I can have a common base there with, and that is going to be, okay, 3. 3 is going to be your common base that you're after here. So the 27, I'm going to write as 3 cubed. So there's 27, and that's to the exponent of x minus 2. Okay, on the right-hand side, I have 1 all over, okay, 81 is again 3 to the exponent of 4. We've seen that value a couple times now, and that's still to the exponent of x plus 3. So what I'm going to do is clean up the exponents on both sides of the equation. 3 to the exponent of this will be 3x minus 6, right? Multiply the exponents together there. And on the right-hand side, I'm going to have 1 all over 3 to the exponent of 4x plus 12. Okay. So the problem here is that my 3 to the exponent of 4x plus 12 is in the denominator. I want to bring that up to the numerator. Now remember, when we do that, okay, I have to make the exponent, oops, it's not working here, 3 to the exponent of, I have to make the exponent negative. So when I do that, it's going to be negative 4x, right? I'm multiplying negative to the exponent, so it'll be negative 4x minus 12. Okay, it gets multiplied by both terms in the exponent there. So now I can clearly state, since I have common bases, that the 3x minus 6 equals negative 4x minus 12. Okay, just equated the exponents. Get the variables on one side, so 3x, this will now be plus 4x. And on the other side of the equation, minus 12 plus 6. So you will have 7x, okay, is equal to negative 6. Okay, and from there, divide both sides of the equation by 7. So x will be equal to negative 6 over 7. Okay, good. In B, okay, last one here, a little trickier, okay, just because the bases, okay, of your powers here, okay, look a little different here, okay. So what I'm going to do is I'm going to take this expression on the left-hand side, and because the exponent, okay, is negative, I'm going to interchange the numerator and denominator, so 216 over 125. And when I do that, I can make the exponent on the outside no longer negative, so it's now a positive x over 4. Okay? 6 over 5 to the exponent of 3x minus 3. Now, why would I do that? Okay, because I know when I look at the question, okay, that the 6 here is going to be related to the 216, and the 5, okay, can be related to the 125. Okay, so I'm going to take the 216 over 125 and be able to write it as 6 over 5, okay, and cubed. Okay, 6 cubed is 216, and 5 cubed is 125. So there's the value of the left-hand side, but don't forget it's still to the exponent of x over 4. Okay, the right-hand side is unchanged. It stays as 6 over 5, okay, all to the exponent of 3x minus 3. Okay, so all I have to do is on the left-hand side, okay, clean up the exponents there. So 6 over 5, this is going to be 3x over 4. And this is 6 over 5 to the exponent of 3x minus 3. Okay, so now I do have a common base of 6 over 5. Okay, I just equate the exponents at this point. So 3x over 4 equals 3x minus 3, like so. Okay, so at this point, I'm going to cross multiply. So I'm going to have just the 3x on the left-hand side, and on the right-hand side, I'm going to have 4 times 3x minus 3. Okay, so when I distribute that 4 inside the brackets, you will get 12x minus 12. Okay, collect the variables on one side of the equation and keep the constants on the other side of the equation. So this will be negative 9x equals negative 12. Okay, so x will equal, and it's going to be a positive value because it's 12 over 9, like so. And then I can divide both sides of the equation by 3 and reduce it to simplest form, which is going to be 4 over 3. And there you go, that's it. Okay. So, like I had said about 3 times, nice short lesson today. Okay, go through, practice that, solving the equations, which again, you can see at the end of each question, I do get a value for the variable. If you're ever worried about it being the right answer or not, substitute it back into the original equation, see if it satisfies the equation. If the left side of the equation equals the right side, if it does, then you have the correct solution. If it does not, you have made an error at some point, either in the calculation or in the substitution back into the original equation. So try and go back and find that. And as always, if you're having trouble, send me a screenshot or a picture of the question you're having trouble with, and I can write all over it and give you some hints and help you solve it, and I will get that back